All right. We're doing linear T. We just put in the 8th grade students and the calculus students. List 1 and list 2, we created a scatter plot. Most of us created the equation. What was the equation? Y, I'm going to write it as y hat equals to a plus bx. What's a?
15 point. Wait, A?
Yeah, we always do a first.
Wait,
15.099.
Oh, 15.099.
09456.
One more digit.
Zero.
0.
Wait, 1.
1.
Yeah, because you could round the next one.
1 plus, what's the slope?
0.4652.
And we call x.
Or you
Now,
could put 0.4653.
okay. Now the point is, whenever you write out equations and stuff, the user don't know what these variables mean. So you either got to put a key and say y hat means it's the number of what? What was I predicting?
How did you get the plus 0.465?
It was in when you did the stat calc 8, it gave you the A and the B.
You're predicting the number of students who will eventually take the AP.
Number of AP calculus test takers.
So that's B right?
That was y hat. That's my y.
That equals people taking the AP exam.
What's the x?
X is the number of students who are 8th grade algebra.
Number of 8th grade Algebra 1 students. If you wanted to, you could write it out like this. Number of AP Calc testers with a little hat equals to the 15.09991 plus 0.4652 times the number of 8th grade students in Algebra 1. You could actually identify your variables within the equation. Or do it the old-fashioned way. Just write it out like this and then label what each variable is. Now, what was the slope of this line in English? Which of those numbers is the slope, A or B? Which one is A or B?
15.098.
That's my A, so that's not the slope. That's my slope. So I'm going to write B is equal to 0.4652. And theoretically, it's rise over run, isn't it?
Yeah.
So it's 0.4652 divided by 1. So what does that mean in English? Rise over run. Rise over run. For every...
For every AP student, or for every 8th grade
For every, good, I like that. Every 8th grade
algebra 1,
student in Algebra 1, what happens?
there is, I don't know, 0.46.
There is, it actually, isn't it?
It's like-
It's actually an increase, isn't it?
There's an increase.
There is an increase in, oh, not in, let me use of, increase of
Like calculus students.
0.46 what? 52 calculus testers. That's what that means. That's what the slope means. For every 8th grade student in Algebra 1, there is an increase of almost a half a student of calculus taking a test. Yes. And now we have to interpret R. This is review. This is one of the reasons I decided to do the lesson. It reviews some regression stuff that you haven't done in a long time. What was R? What did the calculator say R was?
0.8587.
What was R squared while I'm here?
0.7373.
And I up until yesterday, not one student could tell me what R meant. Today, I had a person in second period get R, and they told me what R squared meant. It took a little bit of prodding, but I had at least somebody. Does anybody in here remember what R was called?
Wait, give us a hint.
The first, it has two words. First word starts with a C.
Coefficient?
Yes.
Regression.
And the second word also starts with a C.
Coefficient calculation.
No, never heard of that. Coefficient of, what does R tell us?
Confidence.
The confidence.
I forgot. I know it's like coefficient of.
Confidence.
No.
Correlation.
There it is, Caitlin.
What is it? What is it?
Correlation. It tells us how strong our association is.
Wait, that's R, right?
Yes. It also tells us if it's positive or negative. All right.
Is there 5 points?
Yeah.
Wait,
Hey,
it
I'm
tells
at the
us
E.
what's positive or negative.
We'll do it when we define it. Let me just.
Is that like the whole, like, the closer it is to 1?
Yes. Or negative 1.
When I, yeah, that means it's a negative association.
So what's R squared? Anybody remember that one?
No. Right?
It also is coefficient
Of correlation.
of, but it starts with the letter D.
Determinant.
That's it.
5 points?
No, 10 points.
Determination.
10 points?
I don't know. We'll think about it. Now let's interpret these. Tell me about a 0.8587R.
That's a very strong association.
Very strong or fairly strong?
I'd say, well, maybe
Very
fairly,
strong,
'cause
very strong.
Very strong? Okay. There is a very strong, I'm not so sure it's very, but
Well, it's 'cause
it's
very isn't that
it's
like
not
0.9?
it's close to 0.9. Yeah. There is a very strong or fairly strong or strong. There is a very strong, what's the direction?
Positive association.
Positive. And I heard you say, Manny, you want to use the word association.
Yeah, or like correlate.
Or correlation, doesn't matter. Between what?
Between the number of 8th grade algebra 1 students.
Between the number of 8th grade Algebra 1
And
students
the number of students who will eventually take the AP calculus.
and number of AP calculus exam takers. That's good, Manny. Now, I'd really be surprised if anybody remembered what R squared told us. R squared. Anybody have a clue?
Isn't it that 73.7%?
Oh my God, I cannot believe it. Someone did. Yeah, that turns into a percent. I'll even make it approximately 74%. How's that?
20 points.
So I'm going to write, time I get out of here, I'll have no points left in my point jar. So what does that mean? 74%.
Of the points can be explained by the...
Yeah, that's very low level of it, and I think I may have said that, but let's try to be a little more sophisticated. 74% of the, it's actually not the points necessarily. I mean, it is in a way, but usually it's about the variation.
Oh, yeah.
Can be explained by like an external factor.
Well, not external. The variation of the y values, which is the variation of the number of AP calculus test takers, can be explained by what?
By the graphic.
Nope. By the, not yet, by the x values, which is by the number of eighth grade Algebra 1 students. So what Rebecca said was fine and probably gets credit on the AP test, probably a lot of the points. I just know when I look at the official results, they always keep talking about that the variation is explained. But then later on they'll say, you know, that kind of like gives you 74% of the data is explained. Well, that makes sense. If the variation is explained, that explains 74% of the data as well. So she's not wrong at all, and she's way ahead of the average bear. So those are important things that we have to remember. Now, this is interesting. You know, when we do data analysis of a line, you do realize that we just have a sample of data, right? Well, can you imagine that in reality, there's a whole big pool of data available to grab of 8th grade Algebra 1 students versus the calculus takers? Think about not just this one school, but think about the whole valley. Think about the whole state. Think about the whole country. What if you were able to collect all of the data? That would be called the population, remember? And what if you had the whole population and you could actually create the best fit line? Wouldn't that be the line that beat all lines?
Yeah, because be the best representation
Of all the data, right? Would that not be the true line? Not just the line we got right now, it's the true line. That's what we're heading at. That it's the line that only God could create. Because we'll never know all the data. But what we want to believe is, though, that there is a true regression line that describes.
Is it like the bigger or is it like the bigger the sample, the closer you get to it, right?
Oh, I'm sure that's true. But there is a true line that represents this relationship. And what we're going to do is we're going to run a hypothesis test, because we've done other situations. Remember back in the day of the pennies? We said that the pennies are balanced and that the probability of landing on a heads is 0.5. But we did a hypothesis test. Do you remember what happened?
0.49.
We rejected it, did we not? That it's not true. We rejected it because our hypothesis had a low p-value. Well, anyway, if we had that true line, the theory of line, look at that line would look like this. Mu of y. That line that you have would take all the other lines that we could create, all the other samples, and it would be the average of lines. And there's alpha. That's the same thing as we use as A. That's beta, but we use a small b. Why? Because small b is from our sample. Big B is from the line of all lines. Okay? What we're going to do is we're going to analyze our slope today. We're not going to analyze the y-intercept. You could, but we're going to analyze the slope. And what we're going to do here right now, we got a positive slope, right? So what we're going to do is we're going to test our line for this positive slope. We're going to see if our positive slope is related to the population. So I need to zoom in on the blank space. Here's what we're going to do. We're going to have an H naught. And since we're testing slope, capital B, slope of the God's line, of the population, that B would be equal to 0. Why are we saying that? Because we're saying our null hypothesis that there is no correlation or association. No correlation to number of 8th grade students and number of AP calculus testers. That's my null hypothesis. Your null hypothesis will always be let the slope be equal to 0. But we got a good data here. Was our slope 0? Was our slope 0?
No.
No. Our slope was positive. So I can say my alternative hypothesis, the slope could be greater than 0.
And that means that there is a positive.
Oh, yeah, that means there is a positive association between 8th grade students in Algebra 1 and AP Calculus, the number of AP Calculus
So would that just
testers.
mean like if we find the p-value and we have to reject it again?
Absolutely. And this is what he did. He said, this is kind of funny. without getting into the messy formulas, because he doesn't do that. I'll do it later. It'll be in my video online. We will do this entirely on the calculator. He does tell you, though, that we're going to generate a t-statistics, like Manny said, a p-value, and the degrees of freedom. Well, the degrees of freedom is easy. How many variables are there in regression? 2. There's 2. So we take the number of points minus 2.
Minus 1.
2.
Oh, 2.
Yeah, usually we go minus 1 for a t-test, but because I have 2 variables, we do minus 2. So don't worry, your calculator is going to give you the answer. Look at his calculator. He's going to give you a head start. Most of you have, if you go to stat test letter F. He says it's F in yours. Linear regression t-test. That's what we're going to press. Then we press it, you have to tell it what list you're using. Well, he's using list 1 and list 2, so you probably are also, right? Look at here, beta. Do we want it to be not equal to 0, less than 0, or greater than 0? Greater than 0. And then we're going to calculate it. Once you calculate it, you'll get another screen. The beauty of this screen, it also gives you the t right here. There it is. There's the t. There's the p-value. Why is degrees of freedom going to be 6?
Oh, because of the years.
How many years were there?
Well, we have 1, 2, 3, 4, 5, 6, 7, 8.
8.
Minus 2 is 6.
It was minus 2. It was n minus 2, not minus 1.
Yeah.
And then if you scroll down, you got your A again, you got your B. There's also some other stuff that come up that if you don't have an 84 or higher, you're going to appreciate that this is available to you, okay? When I show you the video that I do for you, you're going to understand what I'm talking about, because you're lucky. Because when I go to your calculator, recording back on, and if you look at his work, there's his H naught, B was equal to 0. There is no linear relationship. Here's his HA, B is greater than 0. There was a positive linear relationship. There's the T. There's the p-value. He also rejected H naught. Then he wants us to do a confidence interval. Okay? Shh. We're right here. We are going to do a confidence interval, except for Manny. Manny can't do this because he doesn't have the function. Back on. And let's see. Do we? Yes. Hi. Are we right? Everything looks good. So there's another problem for you to play with, but I'm not going to do it. I think if you want to work on them, you got 2, 3, and 4. You can practice again. I might save them for a quiz or something. But if you do them yourself and ask me for the answers, I'll tell you.
I got a question.
Yes.
What do we do after you take them?
We're going to take at least a day or 2 to rest.
Can we take them now? Just a day or 2?
Before the exams?
Yes, sir.
We need a break, like, just to mentally.
There's no time for break.
What about break?
So there's
And then we'll get back to something. Yeah, I won't let you down.
Can we just go back to like basic algebra?
No.
Let's go back to geometry.
Boring.
I need to remember basic algebra. That's kind of that's important for us. That's more important for us. Also, it teaches medicinal.
Some of you missed the fun activities on Friday.
The M&M's, todos manoseados.
All right.
Am I wrong?
Yes. All right. Next packet. Look at this data. Yes.
After the AP exam, can we learn medicinal math?
Well, they're what?
Like conversion rates for like medicine.
Conversion of medicine.
Yeah, like from different units of medicine to each
I don't know what that means.
other. Like different measurements of medicine.
I wouldn't know what that is.
who's gonna watch the video? Are you gonna put it on YouTube?
Yeah, I'll put it on YouTube. Where are we at, Victoria? Wow.
I had it, but it had a staple, but it's only one page.
Okay, grab another one. All right, you got another set of data. The data that was collected is, believe it or not, somebody believes that the circumference of your head will predict your your SAT score. Exactly. The bigger your head, the smarter you are. Now, do you think that we are going to reject our H naught? Look at it. Do you think there is a linear relationship between these? Yes or no? No. So you think we're going to reject H naught? That is saying there is no. You're saying reject that there is no. H naught was B is 0.
So we'd have to accept it.
You want to fail to reject it. So let's see what happens. Get the data in your calculator. This data should take you double the time as the other one.
Oh, so it's B is 0 and the other B is not 0?
Right. We'll do not 0 to stand for that there is a relationship.
Hey, sir, where's that at?
The next page.
Oh. Oh, okay.
What's the other packet, Caitlin?
No, the one that's kind of faded.
Yeah, the other packet.
I thought it was this one over here.
Quickly, get it in.
How many pages are in the packet?
This one has like 4 or 5. Front, back, front, back.
Oh, okay.
Because I knew if I didn't give enough, somebody else would say, "Sir, why didn't you give me enough?
Sir, why didn't you give us enough?
You didn't give us very much." So I knew I had to. Oh no, it's the same person asking me. I have a feeling if I'd given you guys one paper, Kayla would say, "Sir, why is this all we got?"
So you're recording, sir?
Yes.
So everybody's gonna hear?
Well, I wonder if anybody will know.
Everybody watches your videos though.
Yo, sure, all 10 of them.
Everybody watching this.
I try my best to hit the reference.
Okay, I'm going to my calculator now. I got it. I can say this. Let's do. This is where the one he wanted us to do the two-tail. Two-tail was T equals 2. Give me that T value again.
T value?
Yep. Anna, have a seat.
What's it? Oh, 2.7276.
2.7276, and the probability that actually 2 times the probability that T was bigger than 2.7276 is 0.013. 13 what?
8138933.
8. That's good enough. All right. So we rejected H naught. So in other words, conclusion. Conclusion, being a fat head
What?
is good
Not necessarily.
because you are smart.
I'm not gonna write that.
I'm wasting my time then.
Wait, sir, can you like zoom out a little? There we go. Yeah, that.
You're a fat head.
Oh, sir.
That
You're,
is so
you're a
sweet.
fat head. You got the fattest head I've ever seen.
Okay, now.
Okay, that's a little. Tim.
Do they even make hats your size?
Wait, no.
Oh, sir. Okay, you just went overboard.
All right, I'm going to go to the PowerPoint now.
Wait. You are smart.
You are smart.
And then T equals
Is it that?
2.7276.
Oh, that's 3.
2P?
2 times, that's my p-value.
Oh, 2 times P.
It's a two-tail test, so 2 times the probability that T was bigger than this is that.
Reject your H now.
There's a card right.
You are smart. You're writing this down? That was a joke.
There's a card right.
Oh, I actually wrote it.
I actually wrote it.
Sir, you. Okay.
So what did the T expand again? I forgot.
What is the T?
Yeah, I forgot.
On that T curve, when we had this curve that looked like this, we get a T value over here.
What does the T symbolize?
It's the same thing as Z. How far away are you from 0?
Oh, okay.
So therefore, we have this area here, but we have 2 of them.
And what's that in regards to T?
That is P.
Okay, but I thought that was P. So why?
P is the shaded region, the area.
So T.
T is just the number that we're at.
So T is a number. P is a percentage.
And P is the area.